What if I told you that the AI systems we rely on every day, from self-driving cars to medical diagnosis tools, have critical security vulnerabilities that could be exploited by attackers? Welcome to the dark side of artificial intelligence. In this video, we're diving deep into AI safety vulnerabilities, the hidden attack vectors that could compromise the AI systems protecting our digital world. I'm going to show you exactly how these attacks work, their real-world impact, and what we can do to defend against them. Before we dive into specific attacks, let's understand the battlefield. AI security isn't just about protecting code. It's about securing the entire AI pipeline, from training data to deployment. There are four major categories of AI vulnerabilities that every security professional needs to understand. First, we had adversarial attacks. These are carefully crafted inputs designed to fool AI systems into making wrong decisions. Think of them as optical illusions for machines. Second, data poisoning, where attackers corrupt the training data to manipulate how the AI behaves. It's like poisoning the well before anyone drinks from it. Third, model extraction. This is essentially AI theft, where attackers steal proprietary models by querying them strategically. And finally, privacy attacks. These extract sensitive information from AI models, potentially exposing personal data that was used during training. Let's start with adversarial attacks, and trust me, this is going to blow your mind. Watch this animation carefully. We have an AI system here, represented by our robot. It looks secure, protected by its defense layers. But here comes an adversarial attack, that red block you see moving across the screen. Here's what's terrifying. An adversarial attack doesn't need to be obvious. Imagine you have an image of a stop sign that an AI correctly identifies with 99.9% confidence. Now, an attacker adds noise to this image, changes that are literally invisible to the human eye. We're talking about modifications to individual pixels that you couldn't detect even if you tried. But to the AI, that same stop sign now looks like a speed limit 45 sign with 97.3% confidence. You can see why this is absolutely catastrophic for autonomous vehicles. The scary part? These attacks can be physical too. Researchers have shown that placing carefully designed stickers on stop signs can cause self-driving cars to misclassify them. We're not talking science fiction here. This is happening right now. Now let's talk about data poisoning, an attack that's even more insidious because it happens before the AI is even deployed. Look at this flow. We start with clean training data, but then attackers inject poison samples. The result is a compromised model that has hidden backdoors built right into it. Here's how it works. An attacker doesn't need to corrupt all the training data, just a small percentage. They might inject images with specific patterns that cause the AI to misclassify only when it sees that pattern. It's like programming a sleeper agent. For example, imagine an email spam filter being trained. An attacker could poison the training data by submitting emails with a specific phrase that they mark as not spam. Later, they can use that phrase to bypass the filter entirely. The terrifying part is that this attack can be nearly impossible to detect because the model works perfectly fine 99% of the time. It only misbehaves when it encounters the specific trigger the attacker planted. Model extraction is essentially AI theft, and it's happening on an industrial scale. Here's the scenario. You see our attacker on the left and a target AI service on the right. Maybe it's a premium image recognition API that took millions of dollars and years to develop. The attacker doesn't have access to the training data or the model architecture, but they do have something powerful, the ability to query the system. Watch those question marks floating between them. Those represent millions of carefully crafted queries. By analyzing the responses to these queries, attackers can reverse engineer the entire model. They can figure out the decision boundaries, the feature weights, essentially stealing the intellectual property. Companies like Google, OpenAI, and Microsoft spend enormous resources building these models. But a motivated attacker might be able to steal the functionality for the cost of API calls. We're talking about million-dollar models being replicated for thousands of dollars. The implications go beyond just theft. Once an attacker has extracted your model, they can study it to find vulnerabilities or use it to generate more effective adversarial examples. Privacy attacks reveal one of AI's darkest secrets. Models remember more about their training data than we ever intended. There are two main types you need to know about. First is membership inference. This is where an attacker can determine whether a specific piece of data was used to train a model. Look at this code snippet. If the model's confidence on a data point exceeds a certain threshold, there's a good chance that data was in the training set. Why does this matter? Well, if you know someone's medical record was used to train a health AI, you've just learned they have that medical condition. That's a massive privacy breach. The second type is model inversion. This is even scarier. Attackers can actually reconstruct training data from the model. That animation you see, face to reconstruction to photo, that's showing how attackers have successfully reconstructed faces from facial recognition systems. Imagine if your face, your private photos, your personal information could be extracted from AI systems just by querying them cleverly. This isn't theoretical. Researchers have demonstrated these attacks on real systems. These aren't just academic exercises. These vulnerabilities have real-world consequences that could affect all of us. Autonomous vehicles. We've already seen researchers demonstrate adversarial attacks on stop sign recognition. One misclassified stop sign could cause a fatal accident. Healthcare AI. Imagine if medical diagnostic AI was trained on poisoned data. Misdiagnoses could literally be life or death. Attackers could potentially cause specific demographics to be misdiagnosed systematically. Financial systems. Banks and trading firms use AI for fraud detection, credit scoring, and algorithmic trading. Model extraction could expose proprietary strategies worth billions, while adversarial attacks could manipulate risk assessments. Biometric security. Your face, fingerprint, or voice print could be reconstructed from biometric AI systems through privacy attacks. This could compromise identity verification systems worldwide. The attack surface is enormous, and the stakes couldn't be higher. We're not just talking about stolen data, we're talking about safety, lives, and the integrity of critical infrastructure. But here's the good news. We're not defenseless. The security community has developed several strategies to protect AI systems. Adversarial training involves training AI models with adversarial examples, essentially vaccinating them against attacks. It's like exposing the immune system to weakened versions of a virus so it can recognize and fight the real thing. Input validation uses detection systems to identify and filter out malicious inputs before they reach the AI model. Think of it like a security checkpoint that screens for weapons before letting passengers on a plane. Differential privacy adds carefully calibrated noise to training data and model outputs. It's like adding static to a radio signal. You can still hear the music, but you can't make out private conversations. However, I need to be clear about something. AI security is an arms race. Every defense we develop leads to new attack strategies. Attackers are constantly evolving their techniques, and we need to stay vigilant. The key is building security into AI systems from the ground up, not treating it as an afterthought. AI vulnerabilities aren't coming in the future. They're here right now. As AI becomes more integrated into critical systems, understanding these attack vectors isn't just important for security professionals, it's essential for anyone who wants to understand the digital world we're building. The questions we need to ask aren't just, can AI solve this problem, but can AI solve this problem securely? What do you think? Are you more concerned about AI safety after seeing these vulnerabilities? Have you encountered any of these attacks in your own work? Let me know in the comments below. If this video opened your eyes to AI security risk, make sure to subscribe for more deep dives into cybersecurity topics. And if you're working on AI security solutions, I'd love to hear about your experiences. Stay safe and remember, in the world of AI security, paranoia isn't just healthy, it's necessary.